In this lesson, we're just going to review a few of the concepts that we covered in the last two lessons. So we are graphing exponential functions, and then we're asked to state the properties of the function. So a table of values is always a good way to find some points. Generally, we use a couple of negative numbers, 0, and a couple of positive numbers. So here we are graphing 2 to the power x, where x is the variable. That tells us it's an exponential function when the variable is the exponent. So we've got 2, let's start with 0. So 2 to the power 0 is 1, 2 to the power 1 is 2, 2 to the power 2 is 4, and 2 to the power 3 is 8. 2 to the negative 1 is a fraction. We put the 2 on the bottom because we have a negative exponent. And 2 to the negative 2 is 1/4. So when we are graphing, we have 1, make this a bit bigger. So we have 0, 1, we have 2 to the 1 is 2, 2 to the 2 is 4, 2 to the 3 is 8, 2, 4, 6, 8. So we know it goes up really steeply. And then we have a half, a quarter, and so on. So we know that the graph approaches the x-axis. That fraction is going to get smaller and smaller and smaller, and it will never get to 0. So if I'm talking about 2 to the power x, the domain is any real number. We don't have any restrictions on the x. The range we know is going to be greater than 0. That graph approaches 0, it does not touch 0, it never gets to 0, and it never goes below 0. So we say y is always greater than 0. The horizontal asymptote is the line that the graph approaches, which is this line here, the x-axis. So that has an equation of y equals 0. So we say the horizontal asymptote is at 0, and the y-intercept is where the graph has a value of x being 0 and y is 1. So there's my y-intercept right there. And those are the general properties of 2 to the x. How does that change if we're going to do 5 to the x? So again, we're going to use the same x values. So we have 2 to the power, or 5 to the power 0 is 1, 5 to the power 1, 5 to the power 2, 5 to the power 3, 5 to the power negative 1, 5 to the power negative 2. So how does that change the graph? So we still go through 0, 1, but this time when we have x as 1, y is now 5, so that makes it a bit steeper. And then we have a 5th and 25th. So what happens to the graph when we change the base to a bigger number is that we get a steeper graph. Everything else stays the same. Okay, so if we're talking about the properties of 5 to the x, everything is going to remain the same. The domain is still any real number. The graph still stays above 0, so y is greater than 0. The horizontal asymptote is still the x-axis, or y is 0, and the y-intercept is still 0, 1. And then finally, we're going to do 1/2 x. Let's do it right. So again, we'll use the same numbers for x. So 1/2 to the power 0 is 1, 1/2 to the power 1, 1/2 squared, 1/2 to the power 3. Then we have 1/2 to the power negative 1 is the same. So when you have a negative exponent, you flip the fraction and make the exponent positive. So that equals 2. And 1/2 to the negative 2 would equal 4. So how does that change the graph? It still goes through 0, 1. This time, when we have negative 1, we get 2. And when we have negative 2, we get 4. And then we get a 1/2 and a 1/4. So what happens to the graph when you change the base to a fraction is the graph now goes down. So Any graph that goes up is called an increasing function. Any graph that goes down is a decreasing function. And the properties, well, nothing really changes. Even though I changed the base and it goes down, the domain is still any real number. The range is still above 0. The horizontal asymptote is still the y-axis, so at 0, and the y-intercept is still 0, 1. Nothing has changed. The only thing that's changed by changing the base to 1/2 is it is now going downhill. Okay, in this question you want to match the graphs to the equations below. So they're all exponential. So I want to look at, and they all have base 2, but I do notice that this one here has shifted up. That +1 is going to shift it up 1. So the only graph that's shifted up 1 is this one. So this one's going to be C. Everything else has not shifted up. This one is my basic 2 to the x, no transformations. So it should have a y-intercept at 0, 1. When I put in 2 to the 0, I get 1. So that's going to be this one. This one, A, has a y-intercept of 0, 1, but it's going downhill. So some sort of transformation has happened to that. So this one's going to be D. It's just your basic 2 to the x. That leaves me with A and B. This one actually has a reflection in the y-axis. My x is negative. So all my positive x's are now negative x's. So that's going to cause, so anything that was positive 1 is now negative 1. 2, 4 would become 2, negative 4. So instead of going like this is 2 to the x. This one would be 2 to the negative x. So all my x's have become negative. So that's that one, which leaves B as the last one. And I can check with B because it has a y-intercept of 1/4. So if I put in 0 for x to find the y-intercept, I get 0 minus 2 is negative 2. And that is equal to 1/4. So that's another way to find out, is to check the y-intercept by plugging in 0 for x and seeing what y-intercept you get. So process of elimination, you can look at, are there any shifts? What's the y-intercept? And you should be able to match it from there. Okay, in the last question, you are asked to find the equation of the function. It says they're exponential, so that's helpful, given the following table of values. So remember that if it is an exponential function, we are going to have a common ratio. If it's linear, you have a common first difference. If it's quadratic, you have a common second difference. And if it's exponential, you have a common ratio. So the first thing we're going to do is find that ratio by dividing each number by the number before it. So 18 divided by 6. 54 divided by 18, and we'll see that we get that same common ratio. In this case, it's 3. So I know it's going to be y equals 3 to the x. So when you're doing your exponential, first thing you do is find the base. Then we have to figure out, well, do we also have a value of a that is not 1? Is there a vertical stretch? So what I can do is I can put in some numbers. So if x is 0, 3 to the 0 is 1, but in this case it's 2. If x is 1, 3 to the 1 is 3, but in this case it's 6. So in order to get 2, I'd have to multiply by 2, and in order to get 6, I'd have to multiply by 2. So after I do my base 3 to the x, I also have to multiply by 2. Okay, let's try this one. So we'll find that common ratio. So 400 divided by the number before it. So this time it's a fraction, it's a half. Then we have 200 divided by 400 is a half. Then we have 100 divided by 200 is a half. So I can see that my common ratio is a half. Then I want to see if there is a multiple of a. So I've got 1/2 to the 0 is 1, but the value indicated is 800. I have 1/2 to the power 1 is a half, but the value is 400. I have 1/2 to the power 2 is a quarter, but the value is 200. So if I multiply each term by 800, I get 800, I get 400, and I get 200. So after we do 1/2 squared, we have to multiply the values by 800, and that is my final equation. So do your common ratio first, and then after that you can figure out whether you have to multiply by a value